This lesson is part of our physics curriculum's Unit 2.2, which focuses on applications of Newton's laws. So we've already spent a couple units learning about Newton's laws and how they're used, where they're seen in the real world. But now we're going to look at how they're applied in real-world situations. And one of the most common applications of Newton's laws is to be able to determine the amount of friction. So we're focusing on friction and how much is acting on an object. So the focus of this lesson is going to be on, well, what is friction? What is it? What is this force that we call friction? What causes it? Where does this friction come from? And are there any formulas or is there any math that we're going to use to figure out how much friction force we have present? So what is friction? Straight from a physics book, it says that it is a force. So remember that forces cause changes. They cause changes to the motion of an object. But friction resists motion or an attempt at motion, whether you're trying to move an object or materials that are in contact. So essentially, friction is that force that keeps us from moving at the same speed in the same direction forever. So Newton's first law says we want to keep moving. Friction is one of those forces that keeps that from happening. Friction is why you have to keep pedaling your bike or pressing on your gas pedal, or why when you drop a basketball and it starts rolling across the floor, eventually it's going to roll to a stop. Friction is present any time that two materials are in contact with each other, whether it is a block on the floor, or it is one of the friction trays that you pulled across the track, or it could be the wheels of your tire on the road. No matter how smooth any surface might look and feel, all you have to do is zoom close enough into that surface. If I zoom in to see where this block and this floor are touching, no matter how smooth it might feel to me, that floor is actually extremely irregular. It is not perfectly flat and smooth. Neither is the surface of that box. So there's irregularities that keep it from being perfectly smooth, at least at the microscopic level. So I've zoomed in with a microscope, and there are these two surfaces that feel pretty smooth to my hands are actually extremely rough and jagged. So the two surfaces have these uneven grooves and jags that catch and pull on each other, especially as they move. You get this constant grinding, grind. Whether you can hear it or see it or feel it or not, it is always happening. So in physics, we tend to focus on actually two types of friction, and here you thought that friction was all the same. In physics class, we focus first on something called static friction, and then a sliding kinetic friction. There's also friction that happens when an object is rolling, but we're going to leave that for a more advanced physics class since rolling motion tends to get a little more complicated. So first we have static friction. So what does it mean that it's static? Static is a fancy science word that means that you're not moving or something is not changing. Static friction is the force that allows you to stand on a ramp. So a relatively steep ramp, you'll still be able to stand on your feet without actually falling or sliding down that ramp. Oh, let me make sure my guy has 2 feet. So we know that gravity is trying to pull you down that ramp. As long as you're on a non-level surface, gravity it's always there, and that force of gravity would tend to pull you down that ramp. So we have gravity pulling us down the ramp. However, we have a force of friction that helps keep us in place. And that's because, again, the surface of that ramp has microscopic imperfections. So does the bottom of your shoe. Those imperfections give you the grip you need to stay still. All those grooves and imperfections are almost locked together and caught on each other. Static friction is often stronger than the other type of friction. It's kinetic friction. Not always, but for most of the situations we will look at in class, static friction is stronger than kinetic. Well, what does that mean? Well, that's why when you're starting to move a car or a heavy object, you need more force to start it moving, to get over those forces that give you that grip and lock you in place. Once you're already moving, you don't need as much force to keep it up. So what does kinetic mean? Well, kinetic is another fancy science word, this time meaning that something is moving. So kinetic is just a fancy word for motion. So in case you ever wondered why the Xbox Kinect is spelled with a K, there you go. So with kinetic friction, you get it anytime you have two surfaces moving against each other. Like I said, when wheels are rolling across the ground, it's a more complex version of this. We're going to focus on sliding objects. We're pulling them or pushing them across a surface. So we have the force of our pull, and those grooves and little valleys and imperfections in those surfaces catch on each other as it's being pulled and moved across. And that creates a friction force that is slowing down. It is fighting against your pull. Usually one of the most common side effects of kinetic friction is heat. So if you rub your hands together, they'll start to get warm. Or if you try running a motor or engine without oil, it's going to generate a lot of heat, which can actually damage the machinery. Again, this friction is caused because those two irregular surfaces catch and grind against each other like sandpaper on wood. So if you've ever wondered why the soles and heels of your shoes get worn down with time, it's thanks to that kinetic friction. As you may have noticed, we love math in physics class, so there are going to be some formulas and calculations you might have to do. And to keep in mind, both static and friction forces are directly proportional to the normal force on the object. So in math terms, the force of static friction is directly proportional to the normal force. Same thing for the kinetic. Now, just so you remember that normal force, that's whenever you have an object on a surface, that surface is pushing up against that object. It's the force of the surface holding it up. We call that the normal force. Normal just means perpendicular. It's always perpendicular to that surface. The larger the normal force, the harder that object is being pressed against the surface, and the more friction there's going to be. Eventually, it was found that as long as you keep that combination of surface types the same, for example, your basketball shoes on the polished wood of a basketball court, the ratio between this friction force and this normal force will stay the same. This gives us a proportionality constant that we now know as the coefficient of friction. So there's a coefficient of static friction and a coefficient of kinetic friction. And engineers and other designers have books filled with lists of coefficients of frictions for thousands of combinations of materials that might come into contact with each other. So if you know the normal force and the coefficient of friction, you can calculate how strong the friction force will be. So we know that the static friction force is going to be equal to the coefficient of static friction times the amount of the normal force. And it's actually the same exact equation for the kinetic friction. However, we would use the coefficient for the kinetic friction for those two surfaces. However, in our labs, we're going to measure those friction forces, and we're going to figure out how strong that normal force is. So we can actually rearrange this relationship. So if I divide both sides by the normal force, it'll cancel out on this side of the equation, so that we see that the ratio between the static friction force and the normal force is equal to our coefficient. And it's the same result for our kinetic friction. It's just a ratio between that type of friction force and the normal force. Well, I hope you enjoyed this attempt at a flipped lesson, but I did want to leave you with some things to think about. First of all, how can we increase and decrease the amount of friction. How can we get more friction present? How can we get less friction present? And why would we want to? Why might we want to change how much friction there is between two objects? And most importantly, is friction always a bad thing? We talk about friction slowing us down and keeping us from doing what we're doing. Friction wears down our clothes and our cars. It makes us have to work harder to do anything and to get anywhere. So is friction always a bad thing? Why or why not? So think about it, and don't forget to take some notes on this lesson. And if you have